So you said you finished the hexadots?
I didn't finish it, but I finished question A.
Okay, well, let's talk about it. Okay, what about it? So there's some dots here.
Yeah. And you draw a hexagon.
Yeah, just like you're doing triangles today, yeah?
Yeah.
So April draws a regular hexagon with 7 dots on each side. How many dots are there on its boundary? Did you figure that out?
Yeah, so the hexagon has 6 sides. So a hexagon has 6 sides, and each side has 7 dots, right? So that's 6 times 7. 2 sevens equal to 14. So there's 3 14s and then I use the 3 10s equals to 30.
So you're focused on how to do this calculation, right? But how do you know it's 6 times 7?
Because it says there's 7 dots on each side.
So it's like this, yeah? 1, 2, 3, 4, 5, 6, 7, yeah?
Yeah.
That's the 7 dots, yeah?
Yeah.
What about these 7 dots? Yeah? Can you see there's a dot that's the same, counted the same, yeah? Do you understand?
Yeah.
So it's not 6 times 7, right?
Yeah.
Because this dot gets counted twice.
Yeah.
Okay, but maybe 6 times 7 could be still useful. What is 6 times 7?
6 times 7. 6 times 7 is 42.
How do you know that?
Because 7 plus 7 equals to 14. So which means there's 3 14s. 3 14s equal to 42 because you use the 3 10s equals to 30 and then the other 4s, and 4 plus 4 equals to 8, so 38, then another 4 which equals to 42.
Okay. Like 3 7s are 21, yeah?
Yeah.
And 2 21s are 42. So. Okay, so then it's 42 more or less than the number of dots?
It's 42 less.
More or less?
It's less.
Why is it less?
Because I counted the same dot twice, so it's less.
Yeah, so the actual number of dots is less, right? So 42 is more than the actual number of dots, yeah?
Yeah.
Because you counted more than you have.
It's 36.
And why?
Because if you have counted them, these stuff, if you double count them, you can just minus the. You can just you can. If you double count them, then there would be two dots. So you could just minus them. So this is 1, 2, 3, 4, 5, 6. 6 minus 42 equals to 36.
Okay, so 42 minus 6 is 36, yeah?
Yeah, because the 6 takes away 2, so there's 4 left, and 4 minus 40 equals to 36.
Okay. Okay, let's try maybe another way to count it, just to be sure, okay? If we have 5... See, here we have 5 dots on each side, right?
Yeah.
And that they don't get counted twice, yeah?
Yeah.
So that's 5 times 6. And then there's 6 dots that are not counted at all, right? So that's plus 6, yeah?
Yeah.
So 5 times 6 plus 6 times plus 6 is actually just 6 times 6, right? 6 times 6 is 36. So it seems like we always get 36.
I know. This is an easier way. So if you only use the 5 in the middle, so that would be 6 times 5. 6 times 5 equals to 30, right? And then you just start counting the ones on the edges. 1, 2, 3, 4, 5, 6. So 6 plus 30 equals to 36.
Yeah, so that's you just did this one first. Yeah, I added 6. Okay, good. Okay, so we counted how many dots are on the edge, right?
Yeah.
Part B asks you how many dots are inside.
Yeah.
Do you know how to do that?
No, I don't know. I don't understand which it says dots inside. But I know it's the ones inside. But how are we supposed to know if there's how much dots are inside?
You gotta figure it out, right? Saying how you're supposed to know is saying that someone else is meant to know more than you, okay? And I don't think we should assume anyone knows more than you in this situation, because the situation is completely determined by the dots. Now, how many dots are inside these ones?
Inside this one, this is 1 dot. If this one has 1 dot inside, this one has 7 dots inside.
Yeah. So this one probably should have more than 7 dots inside, right?
Yeah.
That's good. It has 36 dots on the outside, yeah.
Yeah.
Maybe it has 36 dots on the inside.
Wait, 18?
18.
Yeah, because I looked at the picture. It's the dots inside are between the ones outside. Outside. So they go. So I was looking at the picture. It's so the dots that were inside are between the ones outside. So
Mm-hmm.
I think it's 6 times 3.
Yes, inside this one?
Wait.
Or inside this one?
Inside this one.
This one.
Yeah.
Your reason is very vague, but you came up with a very precise number, so it's very suspicious, you know? Hmm. 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 How many dots are inside?
Now I think it's more than 80. Because there's still more dots inside, of course. So,
See, one way to do it is just to draw it, right? And count. So we had a piece of paper that was big enough. We could just draw a big hexagon, right?
yeah.
And count the number of dots inside. Huh? See? This is even smaller than the one that we have, right?
Yeah.
Because how big is it?
It is
So you could ask the same question about this hexagon, right? How many dots are inside it?
yeah. There are 1, 2.
Hmm? 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 What are you doing?
Thinking.
Counting or are you thinking?
Thinking
What are you thinking about?
about how much dots are in it. Because I don't know how much dots are in it because there's no dots here or here or here.
Yeah, I don't think you quite understood what's going on here. Look. See all the dots here, right? If I go one hexagon further, the dots are gonna be here, but you're not even counting those, right? So you don't have to worry about them yet. So the ones inside this hexagon are all these dots. Yeah?
Yeah.
You didn't really think about this question very much this week, you know? Have you tried counting any of them? I mean, we're asking for how many dots inside the 7-sided hexagon, right? But the same question can be asked for the 2-sided, 3-sided, 4-sided, 5-sided hexagon. How many dots are inside any of those?
So there's one dot in this one, and there is there is 7 dots in this one, and there is 19 dots in. There are 19 dots in this one.
Mm.
And there are 37 dots.
Mm-hmm. You see a pattern?
Huh?
See a pattern?
No.
How'd you get 37?
Because there is 7 dots in this one, and then there is 18 dots in this one, and
No, you said 19.
wait, 19.
That's 19 dots.
19 dots in that one, and then I counted 18, and 18 plus 19 equals to 37.
Yeah, so you added 18 to the 19, right?
Yeah.
Do you see a pattern? If you don't, you might want to keep going.
1, and then
How do you get the next one?
7, and then
So you have 37 in here, yeah?
yeah.
So all the red dots is 37, yeah?
Yeah.
Okay, so that you answered the question that I asked before, yeah? It's how many inside the green. But now, what if you want to know how many is inside the next biggest one? How many inside there? Yeah? Draw it better. So now all the red ones are counted, yeah?
Sixty-one.
61?
Yeah.
Indeed. So how did you get that?
Because counted it. I counted this one because I saw 5 dots. This is 4 dots, but there's a dot here too. So which means if I count 5 here, the rest will be 5, but this is 4 because you can't count that twice, and then 4, 4, 4, and then we already used that and that, which means this is 3, so which equals to 24, and 24 plus 37 equals to 61.
Okay, good. Do you see a pattern yet?
No.
I guess if you don't see a pattern, you almost got the answer anyway. Because this is what's inside a 6-sided hexagon, right? Like that.
Yeah, the 6-sided hexagon. So we just need a.
So if you have that now, that's what's inside a 7-sided hexagon, right?
Yeah, this one.
Yeah. Do you know how many in that one?
It is 6. So which means wait, there's 6 dots in each side. So which means 90.
90. How'd you get that?
Wait, no, it's not 90. I was actually counting the sides too. Well, 90 is the answer to question B though, right? Because if you do another hexagon, I would have to count this too, and this, if I count this, it equals. If I count this is 6 by 6 hexagon thingy, it has 29 dots. 29 dots in total, and then plus 61 equals to 90.
No, why is it 29 dots?
Because there's 6 dots, because there's one here and one there. So
okay, so you're saying there's 6 dots up to here, yeah?
Yeah. So you can't count twice. So that means there are 4 5s, and 4 5s equals to 10. So, and
5 up to here, yeah.
And you can't count twice here or here. So that is 4 plus 10 equals to 14, and a 14 plus 5 equals to 19. Wait, it's not.
Wait, so you're saying it's 6 plus 5 plus 5 plus 5 plus 5 plus 4, right?
Yeah. 5 and 5 and 5 and 5 equals to 10. So which means 10, I mean 10, I mean 20, and 20 plus 4 equals 24, and 24 plus 6 equals to wait, it equals to 30. So it's 91.
Yeah, so it's good that you realize the answer is 91 now because that's what's inside the 7, right?
Yeah.
So, but did you see a pattern in the end? This person got 91 as well.
I still can't see the pattern though.
This person also got 91, but they got it differently to you, see?
Really?
So you see that 91's the answer because you counted them all, right?
Yeah.
But when you see that, look, so what's inside the smallest hexagon? Just 1, right?
Yeah.
What's inside the next hexagon? Well, it's the previous hexagon, right?
Yeah.
Yeah?
Yeah.
So that means, what's inside the next one? Well, it's the last one, right? So every time you're just adding how many on the outside.
Oh.
You're just adding the boundary. So for the smallest one, the boundary is just 1, right?
Yeah.
For the next one, the boundary is 1, 2, 3, 4, 5, 6, right?
Yeah. 6. Then
The next one,
next one is.
where did I get this number from? 1, 6.
Oh, so he was adding them, like doing. So,
Yeah.
so he used a different way. He looked at this, and then kept adding it, adding them, and then yeah.
Yeah.
Baba, okay, write them down in with a bookmark.
什么量？
那个 answer.
可以啊，你快点啊。So you have 1, 6, right?
Yeah.
And how many is in the next one?
The next one.
Yeah. How many dots here?
How many dots in the next one?
So we're saying how many dots are here? How many dots? Yeah, so how do you get 12? It's always just 3 sides. 3, right?
Yeah.
And then 6 sides,
Yeah.
We always count these twice, remember?
There's 4. There's 2 4s, which equals to 8, and then there's you can't count twice of these ones, so that's 1. So that's 9, and then you plus the 3, other 3, and then it'll equal to 12.
Yeah, but look, so you have 3 times 6 minus 6. That's 2 times 6, yeah?
Yeah.
So actually it's always the number of dots minus 1 times 6. Can you see that?
Oh yeah, because that, and then it just 1 times 6 equals to 6, and
Yeah,
then
so the
and then
first one's a
6
special
times
one.
2 equals to like 12,
Yeah.
and 12.
Oh, 3 times 6 is 18. 4 times 6 is 24, see?
Yeah.
5 times 6 is 30.
Yeah.
So you can actually write these as all 5 times 6,
Okay, join.
4 times 6, right now. Now. Okay, just gonna watch for a little bit.
There's a new person here called Michelle Sunny.
Okay, 3 times 6. 2 times 6. 1 times 6. So it's the same as what they wrote, but this is a little bit neater. Because you organize it before you write it all out. So
Like,
you save 5 different
1 times
calculations.
6, and then it's 6 times 2, and then 12 times 3, because the 1 times, and then to 2 times, and then to 3 times, and then to 4 times, and yeah.
So actually you have one, so you have a 1 at the end, which is a bit of an exception, right?
Yeah.
Then you have all these lots of 6s, right? So it's 5 plus 4 plus 3 plus 2 plus 1. Lots of 6, see?
Yeah.
So that's easier to do because you can do 5 plus 4 plus 3 plus 2 plus 1. Actually, you can do 2 plus 3 is 5, yeah? 1 plus 4 is 5, which makes 10. And then 5 plus 10 is 15. So it's 15 times 6 plus 1. Okay?
Yeah.
Lots of ways to do this. What's 15 times 6?
What?
So what's 15 times 6?
15 times 6 is 90.
How do you know?
Because there's 6 tens, which equals to 60, and 6 fives, 2 fives equals to 10. So there's 3 twos and a 6. So which means 6 times 5 equals to 30, and then 30 plus 60 equals to 90.
Oh, that's good. So 90 plus 1 is?
Equals to 91.
Yeah. Okay, let's have a look at the next one. I don't know if we can get much through it. Right. Let's have a look at the next one. This is a bit messy. Maybe something to go through in class today. April then draws stretched hexagons of different sizes. Like the following. A stretched hexagon is made from a regular hexagon by choosing one of the pairs of opposite sides and extending them. Oh, so you have a hexagon, right?
Yeah.
And you make one of the sides really long. Yeah? Like that.
Yeah. We stretch the hexagon and it turns like that.
Have you heard of a stretch limo? Limousine is like a car that's really long in the middle. Okay, anyway. April notices that one of her stretched hexagons has the same number of dots inside it as the number of dots on its boundary. So that's what you have to find. Find a stretched hexagon that has the same number of dots on the boundary, which is these ones, right?
Yeah.
As there are inside the hexagon. So as these ones. Yeah? Understand?
Yeah.
It's like this picture here. So that's part C. Maybe you want to think about that. Do you understand the question? Hmm?
So find so so make a stretched hexagon with the dots on its boundary the same.
So like if you have this stretched hexagon here.
Yeah.
See, this is a stretched hexagon, okay?
Okay.
You stretch this by 1.
Yeah.
So the dots on the boundary, it used to be 6, right?
Yeah.
Now it's 8, see? Has extra 2. Has these extra 2, yeah?
Yeah.
It used to be 6, now it's 8.
Yeah. Because you stretched it.
Okay, and it used to be 1 inside, now it's 2 inside, yeah?
Yeah.
Okay, but 2 is not equal to 8, right?
Yeah.
So it's not what we're looking for, okay? So we want what's inside here to be equal to what's out here. Gotta find a hexagon that does that.
Yeah. So you need to do this like same dots, same amount of dots. So
Yeah, you might have to think about this one yourself because I don't want to just tell you the answer here. Explain why it's not possible to have a regular hexagon with the same number of dots inside as there are on the boundary. You could probably actually explain this one first because you already did.
Explain why to have a regular hexagon with the same number of dots.
Okay, so maybe think about these two until the class starts, okay?
Okay.
Because we don't want to waste these questions like this. But there's at least part A and B. Part C and D we'll do in class, okay?
Okay.